Welcome to Ask and Learn.
Now, a skier is being pulled by a ski lift, and so we can say that this would be a quick sketch of the system. We have theta, we have the skier. Going up the incline would be tension, and then going straight down would, of course, be gravity. And so we can then say that we know that in the cable or in the ski lift, and essentially we're moving at a constant velocity, so we have no acceleration. Therefore, the sum of the forces in the x direction would be equaling the tension force bringing the skier up the incline minus the force of gravity, mg sine of theta, and we know that this is equaling 0 because there isn't any acceleration. And so in this case, the tension force is mg sine of theta, and so we can say that then the work, for part A, the work done by the tension force is going to be equaling mg sine of theta times d, the distance up the incline. And so we can say that this would be equaling 70 kilograms multiplied by 9.8 meters per second squared multiplied by sine of 30 degrees multiplied by 60 meters. And we find that the work done by the tension force in the cable is equaling approximately 2.1 times 10 to the 4th joules. This would be our final answer for part A. Now, for part B, in order to perform this task, the power in the motor must be equaling the work done divided by time. And so we know that this is going to be equaling the tension force multiplied by the distance divided by time. And so this is equaling the tension force. And then distance over time, or displacement over time, this is the definition of velocity. So this would be equaling the magnitude of the tension force multiplied by the velocity. And so we can say that the power delivered, or the power supplied to the lift, or rather to the skier, in order to have the skier travel up the incline, up the mountain, would be equaling mg sine of theta multiplied by the velocity v. So this would be equaling 70 kilograms multiplied by 9.8 meters per second squared multiplied by sine of 30 degrees multiplied by 2.0 meters per second. And we find that the power is equaling 686 watts. This would be our final answer. Again, 1 watt is simply equaling 1 joule per second. That's what the watt unit would mean. And if we were to convert this into horsepower, we can say that the power is going to be equaling 686 watts multiplied by, we know that for 1 horsepower supplies 746 watts. And so the power of the motor is 686 watts, or 0.92 horsepower. This would be our final answer for part B in horsepower as opposed to watts. That is the end of the solution. Thank you.